of all, sirs, now we are recording this roundtable, and I will ask you to kindly introduce yourselves, starting whoever who wants to start, please do it. We are please let me understand who you are and what you do. Please go on.
So who will start? So I will. I will. Probably not. I am sure that I am the elder in that excellent group tonight. I would to thank you so much for this kindly invitation. My name is Waldomiro, but you can call me just Waldo. I'm a Brazilian, but I do have a dual citizenship with an European community in Croatia. I do have 2 addresses. I'm a professor right here in Brazil in materials science. I am the CEO of the Global Composites company, a small company related to the composite materials, both for a school, for a teaching, I would say, and some of other consulting. Thank you so much, John.
He's okay. Okay. Next, please. I'm just hearing what I'm trying to read what our president sent to me. And
okay, I'll go next. My name is Brian Alexander, and I'm thank you again for inviting me to this event. And it's very good to see some ex-colleagues on the call. So hello, Alex and Alexander. Good to see you both after many years together, working together. Essentially, I've been at Solvay for 27 years now, for a long, long time, always working with high-performance polymers. And since 2015, I helped set up the additive manufacturing group in business incubation part of Solvay Specialty Polymers. So thank you again for this invitation.
Oh, fine. That's it.
Yeah, I'll go after Brian. Nice to see you again, Brian. After a long time. Alex Santana. I'm Brazilian, materials engineer with a master's in engineering as well. Worked for a long time in different companies, 20+ years. Some of them at Solvay, so that's why I got Brian with Specialty Polymers there. More recently, I lived in not only in Brazil but also in Asia, and now I'm based in the US, where I'm work with Evonik in the high performance polymers division, where we have been involved in additive manufacturing for more than 20 years now. I'm responsible for the additive manufacturing group in the Americas region, and that's about it for the moment.
Thank you so much. Who's next? Miguel's okay, Brian's okay, Alex is okay, Arash?
Well, hello everyone. My name is Arash Chadravan. I would say probably basically howdy from Texas. I am representing Robos, the 3D printing company. I come from an oil and gas background. My education, I do have a PhD in material science. And thank you very much for this invitation.
Thank you, Arash.
Where is that in Texas? Is that Austin?
Houston.
Houston, okay.
Houston, we got a problem. Everybody has the job. And so, Sammy?
Hi, everyone. Nice to meet you guys. My name is Sami. Thank you first for Sampe, for Sergio, João, to inviting me. I'm very honored to be here today with all those very intelligent people. I'll try to keep up with you guys. And I work at Maxion. Maxion is a multinational in the supplying for the OEMs, mostly in trucks division in Americas, and worldwide we are the highest manufacturing of wheels. I by myself work in advanced engineering and innovation for Maxion structural components, focused in Americas, and we supply for the Americas OEMs like Volkswagen, Mercedes, Daimler, Scania, and etc. And thank you very much to be invited here. I see that I'm kind of the different guy here amongst the composite roads, and we are trying very much at Maxon to be ahead of the competition, to be working in the future, and for sure the connection with you guys. The composites are the future, and I'm really happy to be here.
Okay, thank you so much. Folks, let's start. I have some people with rising hands. Just a moment, let me see who are asking for the word. Just a moment, just a moment. First, just to introduce you, you have received from us a couple of questions about what we are trying to discuss today. My first question is for Alex. Alex, you work for Evonik, am I right? Alex, can you
Yes,
hear me?
yes, I was on mute. Sorry.
Yes. My question, you are work for Evonik, okay?
Mm-hmm.
How's Evonik is considering to use the additive manufacturing process technology to speed up what we have in the traditional composite market?
Yeah, well, I was thinking about this, right? First of all, I have to say that compared to the traditional 3D printing or additive manufacturing, the composite part of that is still its in infancy. So Evonik has been in this industry for 20 plus years, as I said. We're also in the composites world for some time, mainly in additives, in tougheners, all this. And I think there is now where both words are colliding, let's put it that way. So the way I see it, the market evolves in this case is that I can see like companies using tow prags and manufacturing from that and adding tougheners or adding things and making a part out of that. So where additive manufacturing in the end can bring benefits a long time, and speed up the process basically, and moving to the industrialization of the composites on a larger scale, for example, for automotive. That's where I see this, or to consumer goods, for example. That's where I see that this is going, which is completely different from the additive manufacturing for the traditional plastics, filaments or powder bed fusion or photopolymers. This will be completely different segments, let's say.
Mm. This brings me to a question to Arash. Arash, let me evolve the information from Alex. I know Robosi is the, my question, is Robosi, how can you spell it? Robosi is an Italian company, am I right?
I think it depends on what accent you pronounce it. If you just say Italian, they call it Robosa. In America, we call it Robos. I guess Robos, we can pronounce it Robos.
Yes, let me use Robos. Robos is a manufacturing a company that manufactures 3D printers and manufacturing additive manufacturing gadgets. Are you already working in a special machine that can process a composite-based filament or something like that? My question: you have a composite-based printer already?
Well, thank you, Joe, for the question. That's actually pretty brilliant. The composite materials, like Jose said, they're gaining grounds in multiple industries, including the auto industries and motorsport. We are in a business of super polymeric materials, and where we have the polymeric matrix and reinforcing components. So we do have fibers and so on and so forth. So in our portfolio, we have multiple materials today. We have carbon peak, carbon polyamides, and so on and so forth. That these materials, they are adding values to the businesses that they're using it. across the value chain.
Okay, so if I understand you well, you have already machines that can process composites like, I mean, any type of fiber. Am I right?
Yes, we
In
do
the
have
past, I was. Okay, go on, sorry.
No, basically what I was just saying, we have carbon peak, we have carbon polyamide. You know, yes, we do have fibers. They're chopped fibers as part of the matrix, and they add their contributions, like any composite materials, is to the strength of the material, and you know, it provides the material, so you would have the benefit of a lighter material, but at the same time, you know, stronger and more resistant material.
Yes, that's it. So bringing back to Alex, my question evolves to another position. You said that really we're gonna have a transformation shortly based in that's very different from the actual solution that you have, um, um, a material plastic, normal plastic, normal polymer, and you have now different types of polymers that need reinforcements, fibers, and so on. The question is back to you. Have you seen every changes that can you see what's the next step that you can see, knowing about what is in the market now for Evonik to reach what the market needs? My question is, what's the next step for Evonik? I
Alex,
think
you're
you're
mute.
muted. Alex, you're muted.
Sorry. So my question back to you first. Would that be generally on the additive manufacturing world or to specific composites? Because again, these are two different separate things, the
The
way I
question
see it.
is, can you give me the two ways? Can you give me what is the division for the two ways?
Okay. So for the traditional, I would say traditional additive manufacturing, the way I see it is we're now in the transition phase from real prototyping to actually production, right? So, but that's a lot to go still. There's the issues with standardization, for example, and how do you test things? How do you make things they're always the same? These are the challenges for the industry. It's not only about speed, and it's not only about producing parts. It's about the standards. It's about to make sure that the designers have one more way to process polymer in their toolbox, right? So it's extrusion, it's injection molding, it's everything else, but it's also additive manufacturing. Additive manufacturing should be one of these processes that is there. Today, still not at this phase, but we see it getting there. We see more and more production runs, small production runs, of course, for that. And I can see that, you know, photopolymers have their space, and powder bed fusion has its space, and filaments have their space. But I think all three of them will grow up, and the big applications will come. But we are now in this transition phase. The machines are getting better, much better than they were, I don't know, 5-10 years ago. And the better and the speedier they are, that's where we're going to get at some point some standards in the industry. That's what we need at this stage. In the composites world, this is still its infancy, as I said. We need a lot more work together with the machine manufacturers, with the material providers, and this is not only Evonik, but Solvay as Brian here, but all others, to bring up more materials, right? It's depending on the process that you have, the development of a new material can cost easily $1 million. So how do you turn this into a business? That's the question in the composites world. So that to change, to bring back to our realities, how do we put it all together? The machine manufacturers, the material providers, the OEMs, everyone needs to work together to make sure that we have the materials available, the machines available, and the designers know what they want, and what can be done with the technology. So I'll let the others talk.
Let me make another question to you. And how our organization, how Sampi can help you, or can help the market at this point? What is the focal point that you think now this is the point that you have to invest your help, your time to do this? In the
Yeah.
machines or the filaments?
Yeah, and I just saw a question here from Sergio. That's first of all, it's like, you know, educating people, getting people to know what are the benefits of each of the technologies. Again, filament, powder bed fusion, photopolymers, all the different resins that are available, the different materials that are available. You know, what can be done with the technology. Not everything can be done with the technology. I think it's important to also understand what cannot be done. There's not something that will solve all problems in the world, but it brings very nice possibilities for designers, and I don't think they are there yet. They have this idea that 3D printing will solve everything. Not necessarily.
Okay, thanks. Okay. Let me extend this question to Brian. Brian, good afternoon again.
Good afternoon.
It's good afternoon for you. I think it's good night.
No problem.
My question, you know, Solvay is already one of the biggest, maybe the biggest player in the market that works with composites and everything. My question is, how can you bring these words together to have this joining? How a big company that's working for several years with manufacturing, engineering, and everything that is going to make this made a very good and very big story in the markets.
Yeah.
Now is going to face this additive manufacturing new step. How can you see this? What's your opinion about what's the next for Solvay?
Well, again, if you break that question down, I think the future is very, very exciting for Solvay. I mean, but first of all, we've got to thank Evonik for their for actually bringing additive manufacturing to the market with their PA12 and making it mainstream and making it a valid technology. And yeah, we're growing and piggybacking on what the work that they've done and trying to introduce higher performing materials and different types of materials, as Alex says, a different palette of colors for artists to work with and build more exciting things. When it comes to composite materials, we're still very much in our infancy, as Alex says, but Solvay is quite well positioned, and we have this huge composite business, which has been working in composites for now 20, 30 years. And also we have this high performance polymer business. And you're exactly right. What we're trying to do in Solvay is bring the two competencies together. First of all, there's going to be a trend, or there is a trend, to move away from thermoset composites to thermoplastics. I mean, that's a trend because thermoplastics tend to be more recyclable than thermoset composites. I still think there is a place for thermoset composites. That's not going to go away or disappear. But, you know, we are going to try to look at thermoplastic composites. So that's the first thing that could happen. The second thing that can happen is can you combine additive manufacturing to traditional composite or thermocomposite based technologies? And again, this is still something that everybody is looking at and seeing what is actually possible out there. But of course, we're trying to bring of both worlds to the table. And how do you do that? And I think Alex put it quite right. First of all, you try to work with the machine manufacturers, you try to work with the designers, and you try to make sure that you get, you work with the companies that can process your materials to get the best benefits from additive manufacturing. And I say we work with companies like Rebose, who are working on our products to help process them and produce very good parts from our materials. And this is how we see this moving forward. And the question I always get a lot is it going to take over traditional manufacturing, or how much of traditional manufacturing is going to take over? It's a very interesting question, but the fact is we don't know, but we have to be ready. We have to make sure that we have the solutions so that whoever's designing in the future has that in their toolbox.
Okay,
yeah, and if you allow me, just one more question, piggybacking on Brian here. It's in the end, it's all about the environment, right? It's the material providers working to get more materials, the machine manufacturers to be able to process that materials, and the designers that don't know how to use the materials. So it's something that everyone needs to work together. And on the last part of the question there, I don't think they will replace any other technology, but it will enable new things, right? So it's part that it doesn't exist yet that can exist tomorrow because of additive manufacturing.
Yeah, and asking and to answer Sergio's question on the excellence for centers, these are still being built. The mindset is still not fully there in every. I mean, I could say that in nearly all countries. I think even in Europe, where I'm based in Germany. 3D printing is not a kind of like a compulsory course at any of the universities. You have to take it as an option. And it's only when people the next generation fully understand what 3D printing can do, and as Alex says, what it cannot do, then only when you have this mindset embedded in all the people will you have the full potential of additive manufacturing unlocked. And this is definitely something where, people like Sampa can help. If there are institutes, if there are excellence centers, if there are places where we can share information and understanding, that still needs to take place.
Let me roll on this question. You have already prepared yourself, your mindset to train the next generation of designers about that, and you have something, because it's already clear for me and I think for everybody that we are not taking the place of the traditional composite material market, but we are adding something. We are going to another technology that is not going to share space, but have its own space. So we have to restart from the beginning. Our traditional mechanical engineers, electrical engineers, and everybody that was old life working with one type of mindset. Now we have to evolve these guys to try to understand something more. My question is, how can you see? I asked to Professor Valdomiro also to answer this. How can you think that education from the companies and also from us, from SAMP, from the society, will reach the point to understand that is something different and that we have to take the better, but not extracting anything on the past? What I mean, we all times made things once in one way. Now we have another way to do better things or different things. How can we train? How can we prepare people to understand this? This is all. I'm pretty sure that is not in the school area yet. We are not teaching for the mechanical engineers that we are going to have this information. We are not preparing engineers now to face this new challenge. How can you describe what we have to do in the future in any way? Is it clear?
I think
No,
first was addressed
everybody
to Mr. Brian Alexander, the question.
I think the starting about changing the mindset, let's be honest here and very humble. We're still learning ourselves.
Yeah.
We haven't fully figured everything out. We haven't got all the answers to teach all these kids. But we're getting there and we're learning every day. And with new tools and new ways of learning, we're learning as fast as we can. But we don't have all the answers yet, let's be fair.
I want to talk a word about this. It's quite a challenge. Anyway, first, I would say let's figure out how huge can be the additive manufacturing related to the composites. The 3D printing that is already in place for both product design, computer modeling skills, and materials. Also, this challenge pushed me to return back to the university with 60 years old to get my master science in computer engineering. Now I am a master in computer engineering and I'm trying to next step on a PhD in computer engineering. Why? Because we do have in our hands a great opportunity, you know, to use the background. I have 50 years in background in the composite industry, in the old way. I'm still agreeing with Alex Santana 100%. We cannot figure out the same way the actual composite is, the way we do currently for the new composites, or even just the polymers like 3D printing in a, you know, advanced polymers like PEEK, as Alex Santana and Brian told. Anyway, a further step shall cover more types of reinforced polymers, such as thermoplastics, also elastomers. I'm reading some important articles or papers related to tires, aircraft tires, you know, just on lab step. But in 1 year, we'll have a lot of different news. And also fascinating projects allied to mechanical properties based on useful robotics tools. We cannot think in additive manufacturing without computer modeling, material science, and robotics. No way. And a quite attractive aspect of the additive manufacturing is a new age, not just talking about the toolless technology. This is one good thing, toolless. Also, I have a couple of slides if I have time. I want to show you just 2 or 3. But, you know, this is a toolless technology allowing new scenarios, not related just to investment, as said before. Obviously, tooling is a costly issue, but now I'm not talking about just the cost, but I'm talking about the new concept of an effortlessly new design and drawing, keeping the material where it just be. I mean, hollow structures not imagined, even though imagine. Some engineers imagined before hollowed structures, you know, fibers just where the fiber should be. Anyway, not easily reached through an ordinary molding technique. We don't have on our hands nowadays techniques that allow, besides the core materials. Core materials, I think, was a previous step, just, you know, keeping us better to understand all the hollow structures like a core materials can do. But you know, additive manufacturing will do much more. Yep. Yeah.
You said something about tires. Let me ask something to Sammy. Sammy works for Maxion. Maxion also in Brazil do wheels. Sammy, can you give your opinion on this? because it's, I got the idea to make something like that. But my question is, what do you think about it? We have talked about to change the. I know Maxim is leading a transformation from metal to 3D printed or something, or polymers in any way. My question is, can you say what can you see about this technique, and also talk about something about this to that. Can you see the change to print a tire, an airplane tire? What do you think?
Regarding the tire specifically, I'm sorry, but sadly, I can't say too much. I work at the structural components division. I don't have that much experience with the wheels part. But overall, I can see a lot of changes that additive manufacture can bring to the world. It's, as Valdomiro said, it's a very important change of concept of mindset. We work on an industry where our current mindset is on a constant thickness metal sheet, like 7 millimeters, 8 millimeters, and we have to work on for that. So on a big part, like a side member or a cross member, we have that constant thickness all the time, and sometimes you don't need that high thickness everywhere, only on the higher stress points. And because of that, overall, the whole component gets heavier, gets pricier, and additive manufacturing can change that concept, can change that mindset. Additive manufacturing also allied with composites. Composites already can do that even without additive manufacturing, but the additive manufacturing can amplify this new mindset, where we put the material, where we put the resistance only where it is needed. And that's very, very disruptive for our industry. We have been for 100 years working on doing the things one way, and in the last few years, very, very few years, it's changed completely. So, as Brian said, as Valdomiro said, that's a very new mindset. The whole industry, not only the universities, the professionals, the guys that are designing the next electro vehicles, we need to grasp how we can better use that technology. I don't see we replacing all 100% of the manufacturing process that we do today. Of course not, but it can complement. It can solve specific problems that we don't have a very good solution today. Sometimes we have a problem, we have a very specific design that we need to attend to, and due to our current manufacturing methods, it gets too expensive, it has an absurd tooling cost, or we have a solution that's really not optimal. And this kind of process, this new process that are rising, can really help us to be a very precise, a very optimal solution to some very specific problems. Maxim currently is not using additive manufacturing to replace the usual manufacturing methods, but to add to it. Somewhat, I think what Brian talked about, the tooling. Maxim has a very, very big tooling press park, and we use a lot of press tools, dies is a very high investment for us, and it's a very big cost on any project. And what Maxim is doing currently is to use additive manufacturing to do some dies, some tools to produce small batches of prototypes. We are currently printing tools to test some prototypes, test a new design. Then, if approved, we go for a definitive press set. These printed tools, of course, currently is not as good as a definitive tool set, but to test a design, to do a small batch of 10 to 80 parts, to test on a vehicle, to do an engineering loop on the component design, it's very, very helpful. And the composite 3D printing can add so much to that. We can have higher resistance tools, higher speed to produce that, and of course, doing more complex and more demanding geometries on that.
If you permit, João, if you permit, I just want to revert a little bit for that tires. It's not just Pirelli, but there's other big manufacturers. This is a kind of a tubeless, first of all, tubeless tire, but with the different design totally. There's no lateral band, it's just the main cover, and this tire will not be flat virtually. This is made with a additive manufacturing, with elastomers and aramid fibers. Maybe some carbon fibers on the talon, but not all. Very interesting project.
Very, very interesting. Really, really. Just a requirement, people. Whomever is not participating from the panel, that is not talking, please let your system in mute and also keep your camera offline, please, to speed up the connection, please. Thank you, Professor. Professor, let me ask you something, and also for Brian and for everybody, but you first. And Sammy was talking that was telling to us that they are using the additive manufacturing to prepare tools, to prepare machines, making machines to make another machine. My question is, how do you think we can ensure the quality of this parts? I mean, you have printed down a mold. How can you ensure that the part that is made by this mold is completely okay for use?
It depends of the what kind of additive manufacturing you choose. Actually, if you are using, for instance, fiberglass embedded with a polymers like polyamides or PEEK, probably I'm quite afraid about some properties, because the continuous roving, it's applied, and you have a very nice mechanical properties in direction of that fiber. This is a kind of a natural, a tensile strength from that positioning. Anyway, that tooling, maybe you need not just longitudinal or in the sense of the length of the tooling, that property. Sometimes you need more in other direction. So I'm quite afraid, and it is a concern related to use a additive manufacturing to go straight to a tooling, for instance. Anyway, you can do a part. Why? Because the designer or the engineer will think before where the fiber should be, where the resistance should be attended. That's it.
Yeah, if you permit me.
Brian, can you give your position? After that, I will ask to also for Arash and Alex, because I think Arash can say about the machine that they are preparing. Brian, please.
No, I mean, to talk about the tooling is you're only making a prototype part. So you're making one or two parts, as you say, to get the design right. And it's kind of semi-functional. I don't think you're ever going to get the full properties, simply because, as I say, it's a plastic tool. So it doesn't have the thermal conductivity, it doesn't have the cooling, it doesn't have the, the accuracy or the wear properties of an actual fully metal tool. But it's a good start, and it's very useful, and it speeds up the time to go to market of any new application.
Yeah, if you guys permit me, the key is that, as Valdomiro said, the key is on the design, is on the thinking where I need the strength, where I need to deposit a higher quantity of material. And Brian is totally correct. It's currently our technology is allowing some prototypes, some small batches after a few stamping press tools that I'm talking about. after stamping a few parts, sometimes 30, sometimes 50, the wear down starts to really take a toll on the tool. And but that can be solved through other materials. We currently use it PLA, the very simple PLA, but composites on 3D printing and other higher resistance materials can add up those wear down. And our experience as our industry is very standardized to do everything. The automotive industry has very high standards, and we are very good at getting the geometry, the right design, so we can get a good part. What ends up to be our concern is the wear down of the tooling.
Okay, let me roll this information to Arash. Arash, can you hear me?
Yes.
My question is, you are constructing the machines, you are constructing the printers. The question is, how can you have the same standard for different machine manufacturers to have a part that you talking about also the mode? How can you use different, because it's a very new market? Are you aware about any regulation, about any standard, any any norm that can give you the information of what to do and how to measure this? The question is, do you have any standard?
Yeah, well, thank you, Joe, for the questions. I think, as Sami said, when you talk to people in the auto industries, people in auto industry, they say, well, we're just like doing it based on our standards, and what we do is very unique to our industry. You talk to aerospace industry, you hear the same. You talk to oil and gas, they say we're very risk averse. So everybody in the industry, they're used to really the way that they've been doing things for years. And when you introduce a new technology, frankly speaking, there's a bias. So Valdo was saying, even from in an educational realm of things, we've been teaching conventional materials for years. So when all of a sudden there's a new materials coming to the stage and applications, inherently a lot of people start posing questions, and they're all fair questions. They're all good questions, because I think this is a wrong. So Sergio, I saw Sergio was asking, how can the 3D printer manufacturer differentiate itself in this market? I think as a additive manufacturing family, what we can do, this is the justice, to just carefully listen to the questions that they're asking us, because there is a reason. They want to basically make sure that we're not introducing a higher risk level to the operation, whether it's in the auto industry, aerospace, or the oil and gas. But frankly speaking, aerospace industry has been a little bit ahead of other industries. And if we're talking about risks, the level of the risk an airplane is having is a lot higher, I would say, than oil and gas, maybe in a different terms and sense. And I'm not trying to put a dollars or magnitude, but it's very complex manufacturing. So they have to be a very controlled process for parts that we produce for aerospace. And what Robos does, Joe, is really try to basically develop materials, work on materials, but also implant a process that is repeatable and accountable. I heard Alex was talking about some of the barriers that additive manufacturing has, and really standardization is one, frankly, in all the industries across the board. Now, in the oil and gas and energy sector, I can tell you that Robos is leading some of the standardization effort today. American Petroleum Institute is one of the bodies that has some guidelines, and sets some guidelines, for the oil and gas operation. What the Robos is doing today, I have the honor of co-chairing a committee along with some other players, in the oil and gas, basically standardization realm, and that's something that we're planning in the next year or two. We put out materials and guidance that really guarantees the continuity of production in a very reliable manner. Whether that would, Professor Waldo mentioned about, the quality, when we manufacture material, how can we ensure? I'll tell you a short story. I come from the customer side of things to Robos, and, there's a fact there. When we are talking about conventional manufacturing, I think everyone knows that things fail, whether they're conventionally manufactured or they are additively manufactured. There's really a damage mechanism, to all the stuff that we manufacture. I was in charge, in my previous job, of analyzing and looking at, why materials fail, whether they were metallic and non-metallic. And frankly speaking, one of the barriers that I had was that I didn't have a great log of how the material was structured and manufactured. I could usually get a paper, photocopy of a paper that was half in a different language that I can speak, and the rest of it was just some numbers, and that's it. And as an end user, I was happy if I could get my part on time. Now, on the flip side, what I see a potential that additive manufacturing, I think, is unleashing is that, we are giving you the record, the history of the material as it's being manufactured layer by layer, at least as robots. And we think that just creates some accountability for the manufacturers, because if somebody opens the door or disrupts any pieces of the parameters that would, interfere with the quality, final quality of the part, there would be a log of that. So if we manufacture material, there is accountability. So as Brian was saying, I think as an additive manufacturing society, we're also thinking about that we're not replacing anything. I think as the intention is good. The intention is that we're trying to get more efficient, and we're finding ways to be more efficient. Today, for some applications, additive manufacturing on robots, particularly, we are actually going beyond just prototyping. We have functional parts right now in planes, in other machines that are running every day, and this is getting really exciting.
Let me give an open question on it. And how do you think our SAMPI can help you to get the standards? I mean, how can we help you in the markets and manufacturers to find a way to ensure this quality for everybody and to differentiate the best from the worst? How can you see this?
Yeah, I can kickstart this, because I'm really, it is one of the points that every day we talk about. Honestly, we're looking at the TRL level, technology readiness level. And depending on where you fall, with the technology readiness level, we can assign that to an academia, and then they kind of work on that. Obviously the time and span, that they can develop, that will be a little bit longer. And there are a lot of projects that needs Professor Waldo's help and his students, to develop. But there are also some industrial applications that we need to kind of like really speed up. So I would say, depending on the application and where we are with the technology readiness level, we can assign some parties. SAMPI can enable those JIPs, or collaborations with the industry, so we can, show and prove the value of additive manufacturing for different, industries. And this does, Joe, directly helps with the technology adoption. So you at SAMPI is directly influencing this adoption, in my opinion.
Thank you so much. Alex, Professor Waldo? People, can you hear me? Oops, everybody muted. Professor?
Yeah. I'm still agreeing, Arash, 100% with you all. We have, take the opportunity, not just for SAMPI, but SAMPI, it's a fantastic way based on the, well-known acknowledgement. It's accumulation, it's years and years of the good service for the society. So SAMPI can help us, yep, and it is helping also with the university challenges that we had recently here in Brazil. I had the opportunity to work with the students with that with those challenge, so we can move a little with that, synopsis in terms of additive manufacturing as well, thanks to SAMPI. Yep.
No, thank you, Professor. Alex, can you give me your opinion?
Yeah, definitely. I think Arash said that I think some people can really help, put together these kind of working groups, maybe, with different people from the different parts of the industry. Certainly, Sampi has the reach for that. Um, Sometimes we are in one part of the chain, and we normally just talk to the adjacent parts and not necessarily to the whole group as much as we want, but we're not there. And I think that's where Sampi has the broader reach and can help us that, right? That's that. I think I was having this conversation with Sergio the other day. I think that's where putting these groups together, having this kind of conversations that we're having today, but on a broader level, on a deeper level, I think that's where Sampi can really push forward.
Okay, let me give you back the question. And so, do you think it's possible to simply to join everybody together, machine manufacturers, composites, university, and everybody in the same round table, as we're doing today? That's it, Alex. You're muted.
It's not as simple, but yes.
You forgot the designers. You need the designers and the people who are trying to create the final part. And I think you need to have
the
some
OEMs,
kind of
right?
goal, some
and
kind of application, some kind of design that everybody is trying to prove the benefit of additive manufacturing. Or maybe not even the design, maybe a functional tool, because thinking differently with additive manufacturing is what's really missing. Because if you just say, okay, I want to reproduce this traditional manufactured part with an additive manufacturing part, you're not going to succeed, because it's been made traditionally for years and years and years. But if you try to say, okay, I want to create a system or a function, and you have a complete white paper, and you can get the designers, the machine manufacturers, the material suppliers around a table and challenge them, I think that's it's a way to prove what additive manufacturing can do. Okay, then after that comes the benchmarking, the specifications. But it's a fun way to start.
A question for you, Brian. Today, I think today, not in the future, will you enter and fly a plane printed, a printed plane
Today?
Today.
It depends. Additive manufacturing, I would include advanced fiber placement composites in that, because that is also a form of additive manufacturing. Then I would say yes. Because again, people think additive manufacturing is a new thing. I mean, women, when they create babies, you could call that additive manufacturing. It's been around a lot longer than people think,
Yeah. But my question.
My question is, if it was an AFP produced composite plane, I would fly it. I would fly in it, because in composite planes now all the time.
I would say the same. Actually, I'm a pilot. I do have my own, but it is a small. It's a Zodiac, partially a composite. I did the parts myself at my my backyard, and I flew it. No problem. I've flown it since 15 years. I have no problem. Obviously, I have a parachute just in case.
Just in case.
Just in case.
No, but there are a lot. Airbus, Boeing. They already have parts flying, right? 3D printed parts that are flying in these commercial airplanes. Not only military, but the commercial airplanes. They already have parts flying. Even, to be honest, even Embraer has it. So that's it's there. But the structural parts, that's the tough reality, and that's where I think Brian was going with his comments.
You've got 3D printed metal as well. I mean, the nozzle, the GE nozzle, it's in the engine, so
it's already there.
Print the metal, yeah.
So it's already there. That I think it will be more and more utilized, because new designs and new functions and new things. There will be one more process that will be used in the manufacture of an airplane.
Alex, give me an answer. You think those parts are expendable, or I can do some maintenance in metal parts printed? It's better to spare them, to just give them away, or something better.
I'm a materials engineer by
Again.
training, and I'm a materials engineer by training, and my master's was on material selection.
You're muted.
Mm,
No, not muted.
hey, can you hear me now?
Yeah,
Okay.
yeah. Sorry.
So for me, it's a question of how do you design the part? Do you want to design it to be spendable, or do you want to design it to be repaired?
It's like the same, the same that we do together.
Yeah.
And
So for me, it's, I mean, when I did my master's, part of my work was, you know, it's materials process. It's not material selection. It's materials and process selection and design. It's all together. So if you design a part to be repaired, it will be repaired. If you design a part to be expendable, it will be expendable. Doesn't matter the process really. So
okay, using this, Sammy, can you hear me?
Yep.
I know you design parts. You have the idea to design parts, and how can you connect this idea? Alex said that you design parts for that or for different things. My question is, how can when you choose a printer to do your parts or to do your tools, what takes your attention first?
Overall, what our main concern, as Alex is, the design is the key. João, can you mute your microphone? I think, yeah, great, thank you. As Alex said, the design is the key of the thing. If you design the thing to be replaced, to be reworked, or to have maintenance, you can work on that. You start from a principle, and that principle guides you to the selection of the material, to the selection of the printer. I want, for example, may not be a good example, but I want something to be repairable. So I go probably for a thermoplastic material, not a thermoset. So I need a thermoset material. All right, what are the printers that can use a thermoset materials? What are the best thermoplastic, sorry. What are the best thermoplastic materials available, and what are the best printers or most cost effective? Depends on my budget, always on the budget. And we go for that. Like, we start on the design, we start on the blank sheet. What I want with this component, I want a higher lifespan for that, or I want to be replaceable. I want it to be cheap so I can replace it easily, or I want it to be with high effective maintenance so it can last a long time while I keep working on it. So it's like we go for a principle, and that main principle guides us to the selection of the material, the printer, and etc. Have I answered your question?
Yes, for sure. So I will pass the information to Sergio is asking for something, exactly something that I was supposing to ask. So Sammy, let me understand better. You said everything is always on budget. Do you own a metal 3D printer? I know they are very expensive. Or you just have the first generations for polymers, or that's question means that you can do everything, and depends on the necessity. I mean, do you think that you need a 3D printer for composites and also for metals and also for traditional polymers? Do you think about this difference when you decide something to buy?
Yes. Currently, we don't own any metal 3D printers. We have one simple older generation printers for polymers, and the cost is a main issue. I mean, concern of ours. What we main do is how much it costs and how much I will use it. I have a good usage that I expected for this material, for this printer, for this necessity that justifies the price of a full printer. Maybe cheaper to just get the parts that I need from a service. Currently, what we have some studies ongoing. We have some metals that some 3D printed metal that we have some necessities, and the necessity is very small so far, and of course it doesn't justify the cost and the payback for a big 3D printer for metal that's very expensive. So we are quoting some of our skills to do that for services, and as the need arises, as the industry understand that loses its bias to the traditional methods, the necessity goes up, the demand goes up, and we have the full arguments and the full proposal to get a metal 3D printing. And that, of course, will happen to everybody. Right now, it's happening to metal, and in a very near future, will have happen to composites, and as far as the industry goes. I'm talking about metal because my industry is very guided to metal, but I can really see in the future composites having a very different and a very important role. And of course, the same discussion will be happening. Do I need a composite printer or not? What Sergio asked here, if I would print the same part into different machines. Yes, I would. Currently, I do the same part in different machines. I have several presses that sometimes do the same part. The point is we have standards for that. We have standards that assure the quality of the product, and we have tryouts. We understand what are the differentiation of machines, and we have several quality standards to assure that our product is conform what is needed.
That's very important. We are going back to standards. That is a very good discussion. You regarding the Sergio's question, Arash, do you have a printer that can print everything? I think a multi-hole, like a multi-hole machine. Do you have this, or you are aware about it?
I think
is that the replicator from Star Trek you're on?
So, Brian, let me reserve that answer. But I understand, Joe, what you're saying. Really, the desire of the end users, when they're just like seeing that there are some limitations being lifted, the extent of the imagination is where it takes you. And today, I think we are trying to put some realization to that, and then progress it step by step. And I wish we had it. If we were, I think, all the way to the end of it, it wouldn't be fun. As they say, it's not about the destination; it's all about the journey. So we're going through the journey together. And we do have a printer that basically our latest. Again, this is meant to be a think tank, not me talking about our products necessarily, but one of our recent product, without naming, I don't want it to be necessarily very commercial, this conversation. We do have printers that we think are Argo series, and we have done a lot of R&D, hours of R&D. This is what Professor Waldo does in the university. This is what we're in the industry we're doing. To be honest, these are all enabled by hard work and engineering. We have a material scientist working at Robos. So it's just not just a machine manufacturer. We are looking at how the viscosity of the fused filaments, is basically is being deposited. The speed, we're optimizing every single patenting, pieces of the machine, and really as an end product, we're trying to finalize a good properties, mechanical properties, something that. So Alex talked about material selection. This is fundamentally important because we're trying to not to be very disruptive, from the sense that what we promise to our customers, but what we are doing today is we're looking at the analogs of materials that today is conventionally manufactured, in the composites or non-metallic space. So on the first step, we're trying to replace them by the additive manufacturing, bringing those benefits. In addition, what we're trying to do, and we've been doing actually successfully, we've been replacing metals. So this is a little bit space that as soon as we say that, a lot of metallic experts, they just like pull back their chairs and start like, breathing, taking a deep breath, and they're saying, how would you do that? And really, I think the answer is reliability. So at Robos, we're trying to bring the benefits of additive manufacturing by providing reliable parts for the non-metallics. At the same time, we've had aluminum alloys that we changed. We have tungsten carbide that we changed. We have high, and expensive metallic alloys that we changed. And they were necessarily just selected as the material because of their, for example, corrosion properties. Now, if I have a non-metallic that is lighter and it's giving you the same corrosion properties, it is very resistant to abrasion. Honestly, it is liberating for the end users. So they start maybe today, like Sammy said, tiptoeing towards it. But once they get the confidence and the standardization, it really gives that assurance, they're going to run towards it. So Sami, I hope that you'll be having a lot more, 3D printers once that, once you realize the value for your applications. And to go back to the tire analogy, I think we do create a tire as a spare part, as a spare tire. We do also create tires for tractors, and we also create tractors for typical settings. So even in the example of a tire, we are making the same tire. It's the same thing, but with different grades and different functionality. That is exactly what the material selections and the grade that we have, we can deliver to our customers, is. So some of them are spares, some of them are like functional, some of them are heavy duty, like a tractor tire.
Rochelle, I was expecting expecting to have a machine that can print down my axle in the tractor and also print down a pizza for the uptime that we have to be in the company.
So I put it in the
you
R&D
broke my
plan.
heart and my dreams. You broke my dreams.
I think we should talk to the materials providers so they can provide that, and we definitely would just produce it for you through the FFF technology.
I'll give that
pardon me. Talking about pizza, I was visiting a French company right here in Brazil. They started 2 years ago. If you permit, I will say the name. It's quite famous. Sodebo. Sodebo is, yes, they produce pizza with a robotic arm, and this is a 3D printing. Yes, it is.
Yeah, Professor, I was aware about printing food, but I can see Brian is laughing at us. Brian, go on.
Oh, it's fine. I mean, it's definitely a challenging combination. But as I said, for the 3D printed pizza, I'm going to challenge Evonik. I think that's definitely a job for Alex.
I would say that Robos is an Italian company, so from the pizza, we probably are the best. Just saying.
Yep, I'll defer to Arash then.
For sure.
For sure.
For sure.
So people, it leads me to another ideas, lasagna and also pizza and everything. It's almost dining time here in Brazil. I'm very, very interested in this kind of issue. But let me be back to the reality of materials now. Professor, you said about French companies doing food and do special things. Can you say something that we are back to the tire? Can you imagine in the future that you have a machine that can print down the tire, the wheel, the bolts, and the axle and everything? Can you see this in the future? Is something feasible or something completely out of possibility.
Let's
Why
talk
would we
about
need tires in the future?
yeah, please.
Maybe we don't even need tires in the future. Who knows?
This remembers me Back to the Future, but
yeah, maybe we don't use a tires in the future. You know, there's another way coming, like drones. You know, a managed drones. Anyway, just returning back to the Earth, I would responding, João. I would say yes. If you grab the idea, you can do everything based on, you know, Arash and other colleagues discussing. It's a combination of materials and process. It's a combination based on very strong computer modeling tools. Without that technology, we cannot go further. For that reason, I will ask you the opportunity just to show some things. I don't know if I can show you right away here. Just a moment. I have something that I would like to share with you all. Can you see the my screen?
Yep.
Okay. So returning back to the composite, this was a 100% composite. Unfortunately, I got just the picture of the strategy, a advertisement, but the part was there. Was fantastic, a toolless, a body car in carbon fiber. I took this information in 2018. Anyway, I want to go to this picture. This is actually additive manufacturing. We do have at our IPT, this is a Sao Paulo Technological Institute, Research Institute, I would say, IPT or IPT, if you would say. And this machine is an automated tape line, AFL. And this picture I took in 2019, and we run classes there in a post-graduation classes with with those machines, all robotic. You can see the nozzle, very, very complex. This laboratory is called LEL. It's a light structures. And also interesting that is just as this laboratory is the single one in the South Hemisphere. Just returning back that the mechanical properties I was talking about, I would like to share with you all one of the problems we have in composite materials. It's a kind of structure because the material is not isotropic. We do have anisotropic properties. This one was very interesting. And why I am showing that picture? Because thanks to the additive manufacturing, we can embed nano materials. We don't speak in this webinar about nanotech. And this is a good time to talk about the increasing properties thanks to the nano materials. So I'm finishing. I said it was just a couple of slides. I don't like to stress you all like a class. It's not a class, I would say, but the future is just not in the future. The future is in our hands.
Here, João, I wanted to answer Sergio's questions. So he asked Rash, as the investment of the new machine seems to be challenging. Is there any time-sharing business in the market for 3D printers? So Sami, as the end user, you really addressed one of the challenges that the end users have. They want to start, and using technologies, and not just like printers that they're, I don't know, a few $1,000s, but things that they are production units. They could print you something that they have a fantastic material that is reliable. Materials manufacturers, they basically do a lot of R&D, and then it is also produced as a functional prototype. So we thought about it, as Robos. I can speak about that. We try to actually cater a business model that is palatable to different consumers, different manufacturers. And the way that we enable Robos is that we are having Robos distributed manufacturing, as we say. So we say print at the point of use, not at the point that is in maybe some other continents, right? And the way that we enable different entrepreneurs, and including CNC machine shops, that they are actually, really accustomed to the conventional manufacturing, is that we offer our technology to them, and there are some financial mechanism that we help them to get on board step by step, and this way it's easier for them, to get this, as a capex investment. So the capex investment is difficult. We try to offer. So from a technology standpoint, we try to help with the repeatability, the reliability. On the financial side, we just built, Robos distributed manufacturing, that we can, put a unit there. They can start learning, and while they start their services, they start using our printers. We actually do not leave them alone. So imagine that you buy a Lamborghini and then you want to drive it down the street. You're very careful, because, well, I would be very careful because I spend a lot of money on that machine, and I don't want to break it. So usually the way that we do our installations, we do have usually extended 4 days installations. We do have trainings, and on top of that, once the user starts using the 3D printer, we ask them, what is the parts that currently today you're working on, either in your R&D or for your functional prototypes, So step by step, we are with them. We have printed more than 24,000 functional parts as robots, and they are either flying right now or they're in different industries right now working. And so we've been learning a lot. And let's put it this way: we don't know it all, but we've been learning a lot. And we connect all these, expertise to our consumers, to our users. So because materials like PEEK or carbon PEEK, they're not very cheap. And the promise of additive manufacturing is that instead of shaving it off this materials and just leaving some as a waste, you exactly print what you need. And so it is important, but this is not a machine that, you can kind of yes, you can heat print and it's not going to start printing, but there is a lot more goes into that. As Professor Waldo said, this is a perfection of material science. And our engineers, application engineers, who are, by the way, material scientists, they've been looking at this. They've been slicing, lots of CAD files every day in, day out. So they help the end users. So this was a long answer to Sergio's short questions, but that's really the map.
Rush, let me ask an open question for you all regarding exactly that you said. You said several times that is professional printing, professional operations. It's a question to you all. Do you think in the future, in the near future, I think next 10 years, you have a 3D print, a high quality 3D printer in your home, exactly like you have a microwave oven or something? Do you think about this as a possibility, or just a new engineer's dream?
So, João, I would say that this is a very it's a very interesting question. Thanks for the questions. I would say a long time ago, if they would ask you, would you have a cell phone in your hand or in your pocket wherever you go, it's going to be with you, it was a dream. I remember the phones that my parents tell me sometimes they have to go somewhere to start talking to someone. They don't even have it at home. So now we have that cell phone, which is really a powerhouse of technology. We've seen the trend, and without trying to be having the crystal Bob, I would tell you that, we would see additive manufacturing would enable manufacturing closer to the point of use in a very reliable manner that is very efficient. And maybe 10 years ago, like Alex said, he has been in the additive manufacturing business for a long time. 10 years ago, we were not where we are today. And the speed is really astronomical. So things are changing, and consumers really, they're looking at it, and they're just seeing that they can build a lot of efficiencies. Sami can build a lot of efficiencies, introduce a lot of efficiencies into the current processes. It is just a matter of us, additive manufacturing family, provide them with reliable data and process that can ensure that we can give them a reliable part. So I would not box the future. I would say that box is growing.
Okay, so my dream about a spaghetti printer is already a possibility.
Absolutely.
Professor Brian?
Yeah, I think Arash covered the subject perfectly. I just add, the first customers for that technology, they are in place. There's a lot of people that love as a carpenters, as a, not a professional, but, as a hobby, doing a lot of different things at the backyard, at the garage, with the wood, the metals, composites, and things. And the answer is yes. In a very, very short future, as soon we get more, available raw materials and the price decrease a little bit thanks to the scalability. Yes, I am in the queue to buy one.
Okay, and just to add my opinion on that, there's two kinds of levels. I mean, a 3D printer in every house is a possibility. I would not write that off. But a high quality printer, I still think that is the kind of the dream and the goal of additive manufacturing, is to have delocalized production. So do you have one factory printing 1 million parts, or 1 million factories printing part? And if you can change that mentality, if you can change the way things are produced, that can happen quickly. I think it's still a bit of a dream, but 10 years, I think there could be a very good progression in that.
Yeah, I would go in the same direction. Having a 3D printer at home, yes. Having a high quality, high speed machine capable of doing stuff, no, that's not what I see. But I could see one, down the road in the garage that fixes cars. Instead of ordering parts, they can just print the part. From a catalog. Then you have the file and you print the part, and you have the part for your car there, your old car there. So that I see, that I can see happening. For example, you have a tractor down in New Zealand. If you're looking for spare parts, good luck. It will take you months to get a spare part out there. But if you can print a part in the backwoods of New Zealand, that's nice, right? That's the dream.
Yeah, I think we can somewhat correlate to the normal paper printer. Maybe a few decades ago, it was very expensive, only to big companies and etc. etc. Nowadays, everyone has a small inkjet paper printer in house. But the big paper printers with laser settings and that prints hundreds of pages per minute is still limited to companies, to some guys that aims a higher productivity. In some sort of scale, we can think of that for 3D printers at home. I would really love to have a 3D printer in my house to print anything from forks to small figures and brackets for my house and those kind of things. I really hope for that future.
So, Sami, you are in your vision. We can see that you have a printer in your home. You have a 3D printer in your home. You can do everything almost in there. But when you need something very specific, you go to a printing bureau, and this bureau makes the specific part for you. Like you need now to print down a cup, or print down a t-shirt. You go to somebody that has a special machine for it, and you have the service. Am I right?
Yeah, something like that. Like for like if you want to print a photograph, you may be able to print a photograph in your local printer, but if you go to a specialized place that has a higher quality printer, a higher quality ink, you can get that, but really, really expensive and not viable for any household. But maybe a business to someone to have that kind of thing.
Okay, people. Sirs, respecting especially Brian, that is almost midnight, it's almost tomorrow for him. I will open to everybody to in our audience to do some questions. If anybody wants to take the word, please do it, and we will help you to understand that's what's everything. But uh, you wanted to say some final comment about it before the questions?
I want to talk a word. You know, we do have a lot of challenges, of course, in front of us, such as in the composites, meaning I'm more a composites guy, I would say. I'm concerned about the fiber content. This is one of the aspects that we are working hard. Nanotech is quite helpful on that, particularly nano composites. Anyway, we have to improve the surface finishing and others like chemical and environmental resistance, not forgetting the post-consuming destination as recycling. Brian took good words about the additive manufacturing related to the thermoplastics, but you know, in the thermosets, we are quite concerned. Boeing is experiencing a big problem with the post-consumer parts in the carbon fiber industry that they use. By the way, just final words. I think that the 5G that is coming in Brazil, I hope in the third quarter, we will have a nice 5G for the internet data. And so this 5G will allow us to go into the 4.0 industry. Rather than forget it, I cannot do anything with this internet we do have nowadays. So I do understand that the 4.0 industry will support all the concerns, and it will allow a new era for the materials engineering, focusing additive manufacturing, today's subject. Thank you.
Okay, any of our guys want to say something more?
I want to just thank
If
you.
no, I will.
Thanks, Sampi Zhao, for the invitation again. I think it was a great dialogue. You know, as we said, you know, as Alex said, you know, one tractor in New Zealand, back with New Zealand, would take it sometimes. I'll tell you, I'm sitting in Houston, Texas, and sometimes I want to get a quote, just a quote, not the materials itself, and it takes me 2 weeks. You know, the disruptions that we are leading, you know, we are talking about as like participant of this panel, you know, is that what we can print in a matter of hours. You know, this is, I think, very, very disruptive. So thank you for that. And I appreciate Sampi and Sergio for leading the invitations, Jao, for you for moderation of this panel.
I found a question here. Somebody is asking, but our guys in the panel and their words. Just a moment, please.
Hello.
We can hear you. Go on.
I was just reading the question about should R&D focus on developing technologies to replace traditional manufacturing or to add something more? I think that's a really good question. I think we are looking at all types of technologies. There are no rules. This is a disruptive technology. People are always coming up with new ideas. I see probably the benefit of complementing traditional with additive manufacturing, but no, there's always look at what the final part is and what the final functionality, what you want to achieve, and then work backwards from that about the technology that you want to use, because there's so many options out there.
Yeah, if I may, if you think about focusing on replacing maybe the wrong mindset, if you're at putting a bar, you're at putting a comparative standard to the current technology, and there's really, really different things like bananas and apples. So what you have to do is to develop your own technology and see where it leads to without any constraints to what is already out there. If you keep thinking on the current manufacturers techniques, you have to be better, you have to be faster, you may be overlooking another quality of your technique that maybe in the future be far more relevant than we already have today. The current traditional manufacturing have a lot of bias that we should not took on them, we should not worry with them. We have to do what our technology allows us to do and be the best of ourselves, not thinking about what we have today to compete with.
Okay, anybody wants something more? Wants to talk something in asked for the guys in the
There's one question on there about working on nanomaterials, and I think, I mean, we always look at all different types of materials, and I thought Alex will probably give the same answer. I mean, we try to make the materials that people want and that work as best as they can. So yeah, we have to look at nanomaterials and all sorts of fillers and different backgrounds and so forth.
Yeah, as Brian said, it's we work backwards. What is needed? How do we achieve that properties? How do we achieve that? And if that the answer is nano, yes, we work on that. Maybe it is, maybe it is not. So yeah, nano is one tool in the box.
Okay, anybody wants to see something more? So if you have no answers and no questions, no questions, let me ask to Sérgio Datois, our president, to give one more word, if you can, just to end the participation of the people here, and thank you all.
Thank you very much, João. Look, thanks each one of you for being part of this kickoff meeting on 3D printing for SAMP Brazil. This was the first interaction that SAMP Brazil promoted so far on additive manufacturing. I think it's the start. I took note of the actions. I think there are some very strong and valid points to discuss. I also see a match between supply and demand when I hear what Sami is saying in terms of the future and Arashi is saying in terms of product development. I also know, João, that at the CNH you will also work with 3D printing. So there is a lot to be done. I very much like to hear the Professor Valdomiro sharing his thoughts about teaching and nanotechnology and the value of it in additive manufacturing. And as material suppliers, both Brian and Alex share very good balance and thoughts about the decision-making process of how a company should approach it. So I appreciate it. I'd like to wish you all the very best on this longer weekend. Happy Easter, and I look forward to our next interaction. Thank you for supporting SAMP Brazil.
No, thank you again for the invitation. Thank you, everyone.
Yeah, thanks for inviting us.
Yeah,
Good
thanks for the
discussion.
invite, Sergio. Very, very nice. Had a lot of fun.
Thanks, Sergio.
Thank you very much.
So I think we can finish the session now, João. Thank you, João, for facilitating.
Oh, so thank you all. Happy Easter for everybody. Have a safe and good weekend, and also have a good Easter with your family. Please keep attention in the social distancing. Everybody knows that is necessary, and keep safe, keep alive.